This video is on chapter 17, lesson number 3 on conditional probability. For conditional probability, given events A and B, conditional probability is the probability of event B occurring knowing that event A has already occurred. The notation is P parentheses B slash A close parentheses, and that is read the probability of B given A. And there's a formula here. Full disclosure, I really don't use the formula as much as I just try to tackle these things with common sense. So let's look at example number 1. Example number 1 says Mitchell drew a card from a standard deck of playing cards. What is the probability that he drew a queen given that the card was red? So basically, we've got the probability that he drew a queen given that the card was red, right? So the thing about conditional probability that you have to take into consideration is that the given part has already occurred. Also, the given part is going to be your denominator. So given that it's a red card, how many red cards are there in a standard deck of playing cards? There are 26 red cards. So I know that my denominator is going to be 26. Again, the given, which is the part that follows the line or the slash, is your given part. Given that the card was red, there are 26 of those. Of those 26, how many are queens? So that's going to be 2 of the 26, which is going to reduce to 1/13. Let's look at number 2. A number from 1 to 100 is randomly selected. What is the probability that it is a perfect square given that it is an odd number? So again, we want the probability of a perfect square given that it's an odd number. So how many odd numbers from 1 to 100? Well, half, it's either even or it's odd. So half of those numbers are going to be odd numbers. So 50 out of the 100 are going to be odd numbers. Now, of those odd numbers, how many are going to be perfect squares? So 1 squared is 1. 3 is in the next odd number. 3 squared is 9. 5 is the next odd number. 5 squared is 25, which is also odd. I'm looking for perfect squares that are the odd, included in the odd numbers. 7 is the next odd number. 7 squared is 49, which is also odd. And then 9 is odd. Squared is 81. And when you get to 11, which is the other odd number, 11 squared is 121, but that's too high. It's not in that 1 to 100 range. So 5 of those 50 numbers are perfect squares. 5 of the odd numbers are also perfect squares, which is going to reduce to 1/10. All right, let's look at question number 3. It says there are 62 people that take yoga class and 48 people that take spinning class at the gym. 15 people that take yoga also take spinning. If a person from these groups is selected at random, find the probability that he or she takes yoga class if you know that they take spinning class. So what I like to do here on a problem like this is I like to create a Venn diagram. I'm very visual when I'm doing my probability like this with these types of questions. So I like to create a visual of what's happening. And I've got yoga and I've got spinning, right? And it tells me here that there are 62 people that are taking yoga, 48 people that are taking spinning, 15 people that do both. So 15 is going to go in that little section that's overlapping. And then if there are 62 people that take yoga, 62 minus the 15 is going to give me 47 of those are just doing yoga. And then for the spinning class, it said that there are 48 people that are taking spinning. If I subtract off that 15, that leaves me with 33 that are just doing the spinning. So now let's go back to that portion where it says about the probability. Find the probability. So I'm right here. Find the probability that he or she is taking yoga if you know they take spinning. So given that they take spinning, so it's basically looking like this. Probability of yoga given that they take spinning. Now, I just said a few seconds ago that the denominator in your fractions are going to be the given part. So given that they take spinning, how many people take spinning class? 48 people take spinning class. So that's my denominator. And then yoga. Of those, how many are taking yoga? That's going to be 15 out of the 48, which will reduce to 5 out of 16. I do want to show you question number 4 really quick, because number 4 is similar to number 3, but it's got a twist. Number 4 says, of the 30 students in Mrs. Smith's math class, 13 are athletes and 9 are in the band. 3 of the athletes are also in the band. If one student is chosen at random, find the probability that this student is in band if it is known that they are not an athlete. So for my Venn diagram here, 3 of the athletes are also in band. So 3 is the number that's going to go inside. And then for my athletes, let's make the athletes the left side and then the band kids the right side. So 13 minus 3 is 10 that are only athletes. And then 9 minus the 3 gives me 6 kids in band. Here's the problem with this question. This question is dealing with a set number of people. And if you add up the numbers in our Venn diagram, we're missing some students. So 10 plus 3 plus 6 is 19. So that means 30 minus 19, there are 11 students that are just floating out here that are not athletes and they are not in the band. So we're going to need that 11 here in just a second. So let me go back to the find the probability that the student is in bands. So probability that we've got band, given that they are not an athlete. Not an athlete. So given that they are not an athlete. So how many kids are not an athlete? Because remember, that's my denominator. They are not an athlete would be the 6 plus the 11. So that's going to give me 17 students that are not athletes. And how many are in band that are not the athletes? So of those 17, how many are in band? So that would be 6. I think the confusing part about conditional probability is that you have to get the numerator, you're picking from the pool of the given part. You're only able to choose from that given number. All right, so let's talk about two-way tables. A table that records data that pertains to 2 different categories. So that's what a two-way table is. Example here says the table shows the results of a poll of 50 randomly selected students who were asked whether they prefer to watch hockey or football. Find each probability. And part A here says find the probability that you're going to select someone that prefers football given that they are girls, that they are a girl. So my denominator is just the girls. So I'm looking at just these numbers here. 6 plus 16 is 22. That is your denominator. 22 is your denominator because, again, that's just the girls. Of those 22, how many prefer football? Well, that's going to be 6 out of the 22, which will reduce to 3 11s. Part B says probability of a boy given hockey. So the given part here is just hockey. So we have to look at a different part of this table. Given hockey, then just the hockey, prefer hockey is your denominator. So 10 plus 16 is 26. Of those 26, how many are boys? And that's going to be 10. 10 out of 26 is going to reduce to 5 out of 13. All right, let's move on to the next portion. Let's go through number 5. The directions here say to find each probability using the table. The table shows the results of a poll of 150 randomly selected middle school students who were asked if they take French or Spanish. Part A asks us to find the probability that you select a seventh grader who takes French. Now, notice that there's not a line. So when I say that, I'm talking about this line that you see in B, C, and D. That is the conditional part of this lesson. Part A, there is no conditional part. It's asking you to find the probability of a seventh grader who takes French. So there's not a special smaller section. We're looking for a seventh grader who takes French. Well, there are 25 of those. So my numerator is going to be 25. My denominator is going to be all of them. Every single student that was polled. And we know that there are 150 of those students. So 25 out of 150, which is going to reduce to 1/6. Again, you're looking, when you're trying to decide how to do these, please make sure that you're looking for whether or not the probability is conditional or just plain. Part B says find the probability that you select an eighth grader given that they take Spanish. So given that they take Spanish means I'm only looking at the Spanish students. So we'd add up the 23 plus the 12 plus the 33, and that's going to be your denominator, which should be 68. And of those 68, how many are eighth graders? And that's going to be the 33. And that fraction does not reduce. All right, let's move on to part C. Probability that you select someone that takes French, given that they are a sixth grader. Given that they are a sixth grader. So I'm only looking at the sixth graders here. Notice that each time I'm selecting my group based on the given part of the question. So 19 plus 23 is 42. That's my denominator. And then of those 42, how many take French? Well, that's 19. Part D. I need the probability of selecting a seventh grader that takes French. Given that they take French. Given that they take French. So again, my denominator is just the students that prefer or taking French. So 19 plus 25 plus 38 is going to give me 82. Of those 82, how many are seventh graders? And that's going to be 25. And that fraction does not reduce. Number 6 is similar. I'm going to move on to the last portion of the notes here. And this is dealing with frequencies. We've got joint relative frequencies, the value in each category divided by the total number of values, and then marginal relative frequencies found by totaling each row and column. The table below shows the number of first class and coach class passengers on a plane who check one bag, two bags, or no bags. It says find the joint relative and marginal relative frequencies, then find each probability. So, full disclosure here, I don't normally fill out this table because I can find what I'm being asked to find without doing that. I'm going to show you how to do a question, and then we'll talk about the frequency table. Part A says find the probability that you've got a coach class passenger that does not check any bags. A coach class passenger that does not check any bags. So that's going to be 18. This question is not conditional. I don't have a special denominator here. It's 18 out of all of them. So if you add up every single one of these, there's 160 total. Okay? There's 160 total. So for part A, I'm going to take the 18 over 160. So for this section, when it asks for frequencies, y'all, it's basically asking you to translate that into a percent. So sometimes we can ask for probability and it be a fraction. Sometimes it can be answered in the form of a decimal. And sometimes they want for us to put our answer in the form of a percent. And that's what this is about. Well, I can still find the probability, 18 out of 160, and then change that to a percent. So take your 18 and divide by the 160. There it is as a decimal. To change a decimal to a percent, you're either going to move your decimal 2 places to the right or multiply by 100. And it gives us 11.25%. Now, I can do that very easily without having to fill out the frequency table. So what the frequency table is asking you to do is to find the percent or the decimal value for each of these. So, for example, to change the 16 to the frequency table, you would take the 16 and divide by 160. So 16 divided by 160 gives us 0.1. For one bag for the first class, you would take the 12 divided by 160. So 12 divided by 160 is 0.075. And then for the 0 bags, 2 divided by the 160 gives us 0.0125. And then for the total, you're going to add all of that together. So the 0.1 plus 0.075 plus the 0.0125 gives us 0.1875. And you would do the same thing for the coach class. And then the total that's out here on this side, you would add this direction. I just think that's a lot of extra work for something that I can do without having to do all that extra work. So let me show you one more of these. Let's do a conditional. Let's do part C. The probability that you select coach class given that you've checked one bag. Given that you've checked one bag. So checked one bag is a total of 72. Of those, how many are coach? So that's 60 out of 72. And again, we're just going to take 60, divide by 72, change that to a percent by multiplying by 100 or moving your decimal 2 places to the right. And we're going to say 83.33. We'll keep 2 decimals there, 0.33%. So again, I repeat, if you want to fill out the frequency table, you are welcome to do that. I just think that it's a lot of extra work. The main thing, and I said this a second ago, is that when we are finding probability, answers can be left in the form of a fraction or a decimal or a percent. And that's all that you're doing there using those frequency tables is expressing your answers as a percent. So there are your notes for the conditional probability.